everyone. Welcome to STEAM for Tweens. I'm Miss Jennifer here at the Warrenton Library. In today's program, we're going to talk about geology and our planet's solid features like soil, rocks, and minerals. If you picked up your supplies here at the library, you'll have everything you need to complete today's activities at home, except for a plate, scissors, paper, and pencil. If you didn't get a bag, you'll also need to gather a variety of candy bars of your choice, a clear straw, a larger smoothie straw would be the best, and a plastic knife. There are all kinds of rocks and minerals that make up our planet, as well as the moon, Mars, and other rocky worlds. By studying these features, we can learn more about how rocky worlds form and change over time. We have three basic types of rocks on Earth, classified by scientists by the way they were made. Igneous rocks are formed when lava from a volcano cools and hardens, or when magma cools below the Earth's surface. This is granite, which is an example of an igneous rock. Sedimentary rocks form when the elements wear rocks down into tiny particles of dust, sand, and soil. Wind and water help move these particles around and deposit them into layers. As time passes, these layers are cemented together and harden into new rocks. And here we have sandstone, which is a sedimentary rock. Metamorphic rocks form when sedimentary or igneous rocks change after being exposed to extreme heat or pressure without melting. As conditions on Earth change, rocks may change from one type into another. These changes are called the rock cycle. So here is our metamorphic rock, and this is slate. We can tell what type of rock we're looking at, how it formed, and how old it is by studying its characteristics. These characteristics include the rock's appearance, both inside and out, and composition. Studying rocks can tell us how the land was formed and how it changed over time, even on the moon or on Mars. Rock samples brought back from the moon landing were studied and classified also into three basic types. Lunar basalt, which is similar to volcanic lava found on Earth, starts in a lava state and then cools to form hard rock. Anorthosite, formed from the cooling of a large ocean of magma shortly after the moon was formed, and lunar breccia, which has light and dark areas. The light are either pieces of anorthosite or unmelted rock, and the dark are either basalt or melted rock from meteoroids hitting the moon's surface. Scientists are still learning about the igneous, sedimentary, and metamorphic rocks on Mars. On Earth, geologists have the luxury of making observations and collecting rock samples in person. To study rocks and soil on Mars, we have to rely on spacecraft that can use their cameras and tools to act as our eyes and hands. For example, Mars rovers like Curiosity and Perseverance use cameras to send detailed pictures of the Martian surface back to us on Earth so we can explore from a distance. When we compare these images to known substances on Earth, we can better understand and theorize about how the Martian rocks, soil, and minerals are formed. So here is an example of a comparison of land on Mars and land on Earth. And we have a 1 centimeter scale. So that's an example of how we're comparing how similar and different the rocks are. Sedimentary rocks can give us a glimpse into the history of Mars if we are able to analyze the layers and the materials inside the rocks. Scientists are especially interested in a type of sedimentary rock called conglomerate. These rocks are made up of small pebbles of other rock types cemented together. Conglomerates are interesting to scientists because the rounding of the pebbles indicates that water once eroded or ate away at the rocks. And where there was once water, there may have once been life. Scientific evidence indicates that life forms, if they existed on Mars in the past, would likely have been microscopic. So there's our conglomerate. NASA's Perseverance rover is specially designed to investigate rocks like conglomerates as part of its mission to seek signs of ancient microbial life and collect rock and soil samples for possible return to Earth. The Martian atmosphere has weathered the exterior of rocks on Mars for billions of years, erasing much of the information we might gather from simply looking at a picture of a rock. To gather more information from a given rock sample, we need to drill into the rocks and retrieve samples from inside. Scientists call this process core sampling. A core sample, which I happen to have one right here, is a long, narrow piece of rock obtained by drilling into a rock with a special tool that lifts out an intact part of the rock. These samples allow scientists to study the properties and geological history of the Earth, or the Moon, or other planets. They examine the core samples for different layers, which can tell us things about Earth's history, like the climate or the types of animals that were alive at a certain time. Scientists can even figure out when volcanoes erupted in the past by looking for layers of volcanic ash. We can also use core samples to learn about other planets and bodies in our solar system. NASA missions gathered core samples from the Moon and Mars for future analysis. Now, this sample I happen to have from right here in Virginia, somewhere over in the Tidewater region, I believe, from a field trip when I was very young. And it has escaped my memory where exactly it's from, but it is absolutely a Virginian core sample. To classify rocks, we make observations that give us clues about how they formed. Here is some of the vocabulary geologists use to describe and classify rocks. Luster, the sheen, glossiness, or reflectiveness of a surface, such as in this sample of obsidian. So we talk about how shiny and lustrous a rock is to describe it. Cleavage, the tendency to break in flat surfaces, usually in 1, 2, 3, or 4 directions. This example is of lower Mount Sharp on Mars. We can see that it certainly breaks into flat surfaces. Look at all of those layers. Vesicles, or voids, are found when pockets of gas expand within the rock during formation, typical in volcanic rocks, like this sample of basalt. You see the little voids and vesicles, the little holes that are formed there in the rock. Inclusions are impurities found within the structure of a rock from when it was first formed. They range from solids to condensed pockets of gases, often found in meteorites such as chondrites, and can be seen in this sample of andesite. Blebs, or blebs perhaps. While inclusions can take many forms, blebs aren't just chunks of impurities. They are minerals growing within minerals, like in this sample of granite. Common examples are marble or diorite. Homogeneous, which is a level of evenness throughout the structure, such as in this sample of basalt. Or heterogeneous. In contrast, a structure that is not very even and would be called heterogeneous, like this sample of granite. See the difference here between heterogeneous and homogeneous. So one is very similar all the way throughout, and this is a whole big bunch of different kinds of looking specks and particles. Friable. When a sample is very easily crushed, it is referred to as friable. This sandstone on Mars suggests that it could very easily be broken into smaller particles. So it's almost like sandy and gritty. And platy, which is made up of flaky sheet-like layers of rock, like mica. So you can see, you could almost imagine just peeling off a layer of that. All right, it's time for today's activity. Today we are going to make our very own core samples and cross sections of candy bars to see if you can identify what type of candy you're looking at just from studying samples. you can get a cross section by cutting into a solid three-dimensional object like a candy bar to see a flat plane of its interior. Now, this activity works best with candy bars that are at or slightly above room temperature. If your candy bar is too cold, it will be hard to cut or poke with a straw, which is what our next step is, and they might crush or break. If they are too warm, they will be squishy and gooey, and it might be difficult to get a nice sample. So if necessary, you can briefly put your candy bars somewhere to raise or lower the temperature. For example, you can put them in the refrigerator for a few minutes to chill them, or leave them on a sunny windowsill to warm them. Now, some of the candy bars, if you have the ones here from the library, will be easier or harder to break than others. And if you have some of your own at home, then you might have to test it out to see what method works best. But for example, the Crunch Bar, the Butterfinger, and probably the Kit Kat, these are more fragile. So you might even just be able to break them rather than cutting or using our core sample. Examples like the Snickers, the Mounds, and the Hershey's, you will be best, probably be best to use your straw or maybe break as well. The Hershey's you might need to break, but the Snickers and the Mounds for sure will work very well for your core sampling. So let's pull down our camera and take a look at what we're going to be doing here. The first step is to choose which candy bar you'd like to do. I have a variety here. So why don't we go with the Snickers? You're going to unwrap your candy bar and put it on a plate. If you plan on eating this afterwards, remember, ask your grown-up if that's okay for you to do. Then you need to wash your hands thoroughly and keep all of your utensils and straw and knife and whatnot clean before you eat anything. I should mention before we get started that this month's bag does have an allergy warning on it, so make sure that you're aware that these items do contain nuts and other potential allergens. The bag we're giving out has Snickers, Mounds, Kit Kat, Butterfinger, Crunch, and Hershey bars. So please don't pick up a bag if you're allergic to one of these. You can get your own allergen-free candy at home. And this is just what we're able to provide here at the library. Okay, so we're going to take our Snickers bar. We're going to take our straw and carefully poke the straw through the top of the candy bar. And you probably need to twist a little bit as you push down gently. And make sure you poke the straw all the way down through to the bottom of the candy bar. Gently twist or wiggle, and then pull it out. And you can see there is a core sample of the inside of this candy bar. Look at that, we went right through. And you can see the layers here of chocolate and peanut and caramel and nougat that are inside of a Snickers bar. So we're going to use our scissors now to just gently snip off the top. These are not very sharp. Oh, there we go. Not very sharp scissors. That's okay. It works. And so there is our little mini core sample of a Snickers bar. Put your core sample next to the wrapper of the candy bar so that you know which is which and you don't get them confused as you go. Candy bars with a softer core, like Three Musketeers or Milky Way, will be easier to take a core sample of. And harder chocolate bars like the Crunch, you might need to cut in half with a knife or just break apart so that the flat interior surface is exposed. You can get a cross section that will let you see and compare the layers. So here's our Crunch bar. This is one that I would recommend that you just snap. And then you can see, it's hard to see, but there are little tiny crispy crunches that are inside of a Crunch bar. And you can see that layering right in there. Let's do one with a Mounds. That's a fun one. Mounds, we can probably use our straw with because it's nice and soft. Twist that in. Oh, didn't go all the way to the bottom. Let's try that again. There we go. Oh. And so there is our little core sample of Mounds. And you can see that this would be an example of a homogeneous interior because it is all just white coconut. You've got to really like coconut to like a Mounds bar. All right, and then we cut and snip and get our core sample just like that. What shall we try next? Let's see, how about a Kit Kat? We'll see nice, good layers inside of a Kit Kat. Now, you can test out what you've learned by having someone else do this and then showing you the candy bar and seeing if you can guess by the sample which bar it came from. So you can see all of the layers there inside of the Kit Kat. That looked like it had, let's go back and look at some of our vocabulary. That looks a little bit like our Mars surface there with our cleavage, and a little bit like the mica almost, because you can see, you might be able to just peel those layers right off. Doesn't it look like you could do that? So you can try some of the other bars at home and see if you can identify a candy bar or just have fun taking some samples. Many candy bars have multiple layers of different ingredients like caramel and chocolate. When you take a core sample using a clear plastic straw, these layers are clearly visible inside the straw. You can do a side-by-side comparison of the layers in different candy bars. You can also match an unknown sample to an existing sample to identify the source of the unknown sample. So like I said, you can have someone else try and trick you and have you guess which kind of candy bar you're looking at. For your cross-section samples, you might want to make a detailed sketch of the sample. The sketch should show the interior cut surface that is flat and any important details of the exterior. Take notes describing the physical characteristics of the cut surface of the sample. Take note of the sample's texture, as a geologist would, as texture can be used to help determine the origin of a rock. Don't use any food terms, so don't say that it's chocolatey and covered with peanuts or caramel or what have you. Say the outer layer is a thin coat of light brown material containing cream or tan colored round chunks. So that might be a chocolate candy bar coating that contains peanuts. Now, if you aren't able to use actual candy bars for whatever reason, I'm going to hold up some cross sections here so that you can do this at home. This is the inside of the Milky Way. And for an example here, this has a medium brown layer, which covers the top half is a shiny, smooth, medium tan layer, and the bottom half is a dense, dark buff layer. All right, and now here is the inside of a Snickers. Think of some terms that you could use to describe that. We have the inside of the Hershey bar. There's another homogeneous structure, dense medium brown sample. Let's see, we have the inside of the Butterfinger. How might you describe that? That's another one that looks a little bit like that surface of Mars with our cleavage. We have the inside of a Kit Kat. You probably got a better view of that even on the camera when I held it up in real time. But here is a photo of the cross section. Here's a better view of our crunch with all of the little pockets of Crispies. And then here is our mounds. So if you are not able to get candy at home, you can just pause the video and take a look at our photos. So you can always go back and watch the vocabulary terms portion of this video for more ideas of terms that you can use that might apply to your sample. I hope that you enjoyed today's program. Come by the library to check out these books featuring more information about geology. In next month's program, you'll learn about ways that you can harness the power of the sun. Don't forget to register for a supply bag to pick up everything you'll need to participate at home. In the meantime, head over to our website, fauquierlibrary.org, click on the research button and select Science, Math, and Environment from the list shown. There you'll find Science Online, a resource featuring articles, videos, experiments, and activities to enjoy on a range of scientific topics. Thanks for watching.